So we are still working on this same sample question. Okay? So the math test was done. The population mu was 60. Standard deviation was 8. Then we did the special tutoring and we found the sample mean equal 70. And they are saying that we need to do this hypothesis testing at alpha equals 0.05. So this information we have. We also have the information that when we do a sample from this population, we do a sample of 100 people. So we have the sample size, we have sample mean, population standard deviation, and the level of significance alpha. Everything is given to us. So based on these, we are writing that H sub 0 mu equals 60. So our alternate hypothesis, or according to the text it says H1 will be mu not equal to 60. Remember what the issue was? The issue was when the students they took the test first time, the population mean was 60. Then we selected a sample of 100 students, gave them the same math test. The score went up to 70. That's the sample mean. Now the question is, did that special tutoring have any effect to increase the population, to increase the sample mean, because it was 70, whereas the population mean was 60. So we are saying, you see, alternate hypothesis, you will always say that it is, which is not the right one. That's the, the null hypothesis is like it's not there, but alternate is, it is there. We know that 60 was the population this was the fact before the special tutoring. After the special tutoring, this shouldn't be the fact. This should change. Based on the information we have, which is the sample mean is 70. If the math test is making any impact, then this population mean should be changed from 60 to whatever. So, but since we had, so every time you write these things, first thing, which hypothesis you should write first? Can anybody guess? Between this null and the alternate, before you write those, which one you should write first? Before you do the calculation. Because you have all the other information. Think about it. We had the math test done first, without any special tutoring. The population mean was 60. Then we took a sample of 100 individuals. We gave them the special tutoring. They took the exam. The population mean, the sample mean went up to 70.
60.
So, kind of. That means, and then we are saying, okay, if we found that this mean for these 100 people went up to 70, that means, is it because that special tutoring made any impact on these people? If so, then if we are offering that same special tutoring to the whole population, then this should not be 60. Right? This was 60 before the special tutoring. If we are offering special tutoring, not just these people, the whole population, then this should not be 60 anymore, this should go up. This should not be 60, that means the mu not equal to 60. So whenever you are doing this, always write the alternate hypothesis first. Alternate hypothesis is the one you are expecting. And then the null hypothesis is not the one you are expecting. Are you guys with me? Did I explain it okay? Or you are still lost? Okay. Again, look at the information we have. First thing, the math test was given to all freshmen, the whole population of freshmen at ISM. They took the exam, their average was 60 and standard deviation was 8. Then the university administration, they decided to select a sample of 100 from those freshmen and offered them special tutoring, gave them the same math test, and their mean from this sample was 70. Now the administration is thinking, well, what if we offer the same thing to the rest of the population and then they take the exam? Is this thing going to go up? This population mean going up, meaning this population mean is not going to be 60. It was 60 before the tutoring. So after the tutoring, it should not be 60. And that's the place where you start your hypothesis. So mu not equal to 60, that's your alternate hypothesis, what you are expecting. But your null for hypothesis will be mu equal to 60. And based on this, we will start our calculation. Ernest, are you lost? Anybody else?
I have a question. How would you
Yes, sure.
Where did you get the 100 from the sample 100?
Here. A random sample of 100 students. I can write it. You don't have that?
Okay, let's see.
Yeah. Okay. So, first thing we wrote, the alternate hypothesis is mu not equal to 60. Not equal to meaning we are looking at a two-tailed test. This sign always indicates two-tailed test. So we are going to look at the right tail and the left tail. Again, alpha is 0.05. We are looking at both tails of the car. So 0.05 is equally distributed on either side or either tail. So on each side we have 0.025 on the right side, 0.025 on the left side. Then we looked at the Z table and page number 226, if you look at column number 3, column number C, right here you will find that 0.0250 and the corresponding Z value. So the Z value is on this side it will be 1.96, on the left side it will be minus 1.96. Now we need to do the calculation. This is the next step. So what are the formulas we have? The main formula we are going to use is Z OBT of 10 equal M or X bar minus mu divided by xm. I tell you what, don't worry about this x bar, keep it as m. What is this sign? Sigma m. We did this last time. Right.
Stay there.
Yes, absolutely right. Yeah.
Give you a break.
Okay.